Okay, this video will talk about the area strategy for multiplication of larger numbers. We know the area talks about the square units inside of a given quadrilateral, or any shape really, but we mostly focus on quadrilaterals. The students are currently learning about how to take a multiplication problem and turn it into a problem that focuses on area, such as, imagine this were a house, and if you have a number like 54 times 3, you'd have a 3 by 54. How to chunk that number into something simple like 50 and 4 could easily become 50 plus, so this length is 50 plus 4. And all of a sudden you have in your house a room that is 50 by 3 and a room that is 4 by 3, because this length and this length are the same. This is also a 3. So we've been calling this the living room, and this one's the bedroom. So if you know how big your living room is and you know how big your bedroom is, put it together. That's how big your whole house is. So let's talk about the area strategy with a few particular problems. We'll start with the problem 64 times 4. Okay. I'll solve it the regular way first, using the standard algorithm. Do the ones times the ones times the tens. 4 times 4 is 16. 4 times 6 is 24. Add 1 is 25. That was also doing the shortcut way. We know that there's nothing to multiply 4 by here, so I just pulled the 2 down. So we know the answer is going to be 256. That's a really good way to verify that you're doing the area strategy right, is to do it the standard way first. So now let's go ahead and make the array or area model by drawing a rectangle. And since it's a 64 by 4, I know the shorter length is 4 and the longer length is 64. I'm going to go ahead and break that into a living room and bedroom, because I want to make these more friendly numbers, and it just so happens that 60 and 4 would break apart really nicely. If you look right here, we have 6 tens, 4 ones. You could just break those apart. 64 is the same as 60 plus 4. So I'll go ahead and write that here. My new dimensions are 60 and 4. Here's 60, here's 4. Together, from start to end, the whole line is 64. But now that I've done that, I can kind of stop thinking about this whole line, and I can just think about the larger rectangle, the living room, if you want to call it that. 60 times 4 is the same as 6 times 4 with a 0 at the end, or 4 times 6 with a 0 at the end. 4 times 6 is 24, and since there's a 0 at the end, I'll put that there. So my living room has an area of 240 units squared. Now my bedroom, I know this length is 4 because this length is 4. My bedroom is a 4 by 4. 4 times 4 is 16 units squared. Now, like I said, if I want to know my living room, my whole house, I have to add my living room and my bedroom. So I'm going to go over here and make a vertical addition equation. 240 units plus 16 units. Do what you know to do to solve. And then my entire area is 256 units squared. Now I can look back and compare it to the work I did earlier and see that my strategy is right, because I can verify it by solving it a different way. Here's another example. For this one, we'll do 37 times 5. 5 times 7 is 35. 5 times 3 is 15, plus 3 more is 18. Again, use that little shortcut way because I know a 0 is here. So 185. I'll go ahead and use the area model to solve 37 times 5. And 5 from my shorter side, and 37 from my longer side. I know the number 37 is comprised of 3 tens and 7 ones, so all I have to do to make it a little bit more simple is break that apart. 37 is the same as 30 plus 7. So I'll break this into a piece that is 7 long and a piece that is 30 long. Again, Don't need to worry about the entire length of the whole house now because I know the length of the living room, and that's what I want to find first. The living room is 5 by 30 or 30 by 5. 5 times 3 is 15. So 5 times 3 with a 0 at the end is 15 with a 0 at the end, which is 100. I know this length is 5. And just like in the kids' times tables, they meet at the middle, and this area now is 7 times 5, which is 35. Vertical addition. And I can check back with my standard algorithm and find that it's the same answer. So that is the area strategy. Again, we're thinking about taking the whole of a two-dimensional area, parsing it into two pieces that are easier to solve and makes the numbers a little more friendly to multiply. Once you find each of the two pieces, you can put them back together to find the whole.